while and on, without a clue, without a sign, without grasping it. The real question to be asked: where have I been? I'm a shapeshifter at post masquerade, hiding both face and mind, all free for you to draw. I'm a shapeshifter. What else should I be? Please don't take off my mask, revealing dark. Moments of calm, nothing left to be found. A mirror right in front of me, that's where I find an empty glass, reflecting that's a truth. It's telling words not to be told. I need that mask. I'm a shapeshifter at post masquerade, hiding both face and mind, all free for you to draw. I'm a shapeshifter, chained down to my core. Please don't take off my mask, my place to hide. I can't tell you how to see me. Just a cage of bones, there's nothing inside. Will it always be burning down the walls? Is there a way for me to break? I'm a shapeshifter at post masquerade, hiding both face and mind, all free for you to draw. I'm a shapeshifter, have no face to show. Please don't take off my mask, my disguise.
Hello, everybody. The purpose of today's lecture, in air quotes here, is to go over any questions that you might have for exam number 1. Before we actually do that, I want to first direct you to what I would like you to do, which is type things in the chat, which you can't see on the video yet. Once I go over to here, you'll be able to see it. But get those questions in so that I can have something to work with. In the meantime, I'd like to talk a little bit about how the exam will work. So, the exam's a little different than it is for quizzes, and the ways that it is different are mostly administrative and on my end, but there are some things that I want to remind you of, and so these are all in the syllabus, which I'm going to make sure that I'm reporting the correct information to you so that I don't contradict myself. But some general comments on the exam. So the first comment is that it's only available for one day. Okay? That day is Monday, which should be on the screen there. I believe it's the 26th. Yeah, that's what it says on the screen. Let me check the calendar. Yeah, that's the right day. Okay. The exam will open at midnight that day, and then it will close at 11:59 p.m. Okay, so you have 24 hours to do your attempts at the exam. It's the same as quizzes, you get 2 attempts. Differences between the quizzes and the exams are that at no point do I release the key to the exam, and I won't show your score until all of the exams have been collected. So when you finish the test, it will just say, "Thanks, you finished the test. The instructor has chosen to withhold scores," and you won't have any idea how you did until everybody is done. What that means for you is that you might think, "Oh, I did not great. Let me go study for a little bit more and then take it again." But you won't have a number to base the assessment on. You have to gauge it yourself. Or maybe you'll think, "Oh, I did just fine. I don't need to do it a second time." And that's okay too. Like your job here is to gauge your own progress on the material, decide whether you should take it a second time, and then basically wait until I have all the exams in and I release the scores. Again, I'm not releasing the key for any reason, so you will only get to see your score, which will appear in the gradebook once I have everything in. Please keep in mind that I do have students that are making requests for different exam days. What that means is that since I'm allowing some people to take the exam on Tuesday because of a scheduling conflict that they might have, you won't get to see your score until at the earliest Wednesday. How many questions? I don't actually have an answer for that. I try to do... It will probably be about 25 to 30 or so. You have 75 minutes to do it. And Maya really wants to say hi. Hi, Maya. Is there a reason you decided not to give us a score in the key? Yes, it's so that you don't cheat. If students take the exam and do really well and have been photographing their answers to share with other students, then that unfairly benefits people who don't see that information. If I don't show you the score, you have no idea, because I have learned that students have no confidence in their ability, which is not necessarily a justified thought. And I don't mean to say that as rude. I just think that as students, you guys have no concept of how well you are actually doing. Which is something you kind of have to develop. Like, as a student, it's hard to develop the confidence that, hey, I actually know how to do this stuff. Because I'm kind of the same way, too. When I learn to do something new, I am sitting here listening to my cat whine, Maya, please. Maya, stop. Where was I? Sorry, the cat is annoying me. When I am a student and learning something new, I do the same thing. And I'm just like, I have no idea if I'm doing well or not. But the more practice that you do, the more confident you will become. Is there a reason the key won't go out even after every student has taken the exam? Yes, because if I post the key to the exam, then I can't use the exam again in the future. And it takes me to write this exam on Canvas, with how frustrating and obnoxious it is, will take me at least 6 hours of programming. And I don't want to have to constantly start over on that again. No, it's terrible. I cannot emphasize enough how shitty Canvas is for online testing. Like, you guys hate it, obviously, but I hate it even more. Can we ask you what we got wrong so we can fix it for the final? That is not the purpose of an exam. The purpose of an exam is for me to assess what you know, and that's it. I can assess and address things on quizzes because that is their purpose. The quiz is sort of a check to see, like, hey, what do you know? And then you can review that. But the exam is not. The exam does not cover any new material. It is all old material that I have tested you on before. The questions may be different, but the content is not. So to answer your question, no, I will not tell you what you got wrong on the exam. I will only give you your final score. It's the same way for the final. You don't ever get to see your final after you've taken it. You just get a score. Let me put this on the screen. This is like... That's the syllabus. I'm just reading the syllabus there. We can hide that window capture. Other questions. These are actually good questions. Like, don't feel like me saying, no, you can't do that. I'm not intending to be condescending. In fact, I know that you guys probably have not heard this side of the administrivia equation before, and it's good to see it. It's sort of frustrating from my perspective too. Like, I hate exams because what do exams do? They cause anxiety in students. They are high stakes, and they're sort of like just one and done. Like, you only get one shot at it. I try and alleviate that by giving you two, but from my perspective, they take a lot of effort for me to write. They take a lot of effort to grade, like in person. Online is auto-graded, so I don't have to worry about that part so much. But I don't get very much information other than, like, a timeline of, oh, you knew this here, and I have 2 data points to work with. So it's not super informative. Like, you could know the material and do poorly on an exam, or vice versa. So the best way to ensure that you do well in this crazy system that we have established in academia is basically what Nate said there. Make sure that you know all the concepts from the quizzes. If you know how to solve the quiz problems and you can get the answer that's shown, you're in great shape. If you have questions about specific quiz problems, now is the time to go over those too. So those are fair game, by the way. You can ask me quiz questions during these Q&A sessions. I don't think anybody has yet, but you're totally allowed to do that. I realize that the answer key just says a number, which is not super useful. Like, I don't have the work shown on the key because you can't do that. But if you have, like, a specific question that you got from your quiz, I can't look it up for you during this because that would take me like 10 minutes to do. But if you dig around in your file and you can, like, type out the question, I can make up a variation of that and we can solve it. Well, actually, let me just go into the quiz publisher here. Yeah, I can access all of the versions, but it will take me time to get to them. So if you say, like, quiz 2 number 4, I won't know what you mean because the order of the questions is scrambled too. That's more or less what I got. There you go. I can find that. So quiz 2, question about speed of light. So that's unit 3. Now, I have 2 versions of that question that I posted. I gotta find... I gotta go in the item bank. I should show you guys how miserable this is sometime. Let's see, Unit 3. I don't know which dimensional analysis it is. It's not this one. So, Meg, I have two of them. Did you want the one that asks how many miles away is the distant object, or how many seconds does it take for a photon of light to travel to a satellite? Nate, we can do that one next, sure. Oops, my Photoshop didn't render properly. There we go. Oh, I don't even have my tablet out. Let me get that real quick. Maya finally gave up. She was like, oh, I guess you're working. What is my cord tangled on? Oh, video game controller. Yeah, we don't need that right now. Okay. Let me do this. Let's see if this works. Oh, that's not going to work because it's going to... Let's see here. So this is what I see. So I need to fiddle with this a little bit. You get a little behind the scenes preview. But you'll notice that I have a variable just set in there where it says the word time, because it just randomly chooses a time. So let me try this. So I gotta make this a little bigger. So I'm going to... How am I going to do this? So return... So I'm just going to make a blank quiz. Student questions. We'll just do that. And it's not worth anything. This is how I make your quizzes. These are all problems that I have programmed. And I have pages of them. It's super frustrating to deal with. Which one was this? Was this 2? Yeah, so let me just add a random version of this. And there's the answer for this problem, but that's not super useful to us right now. So I'm just going to do that and make it bigger. We'll just scroll this over. See if I can... There we go. I can barely read that on my screen, but hopefully you guys can read it. So it says the speed of light is 3 times 10 to the 8 meters per second. Suppose a photon is sent from a distant object to a sensor on the Earth's surface. Excuse me. If a photon traveled for 4.66 seconds, how many miles away is the distant object? All right, so how do we do that? So I'm going to draw a little picture. So here is my distant object out in space. We'll just say it's like a... I don't know. Some sort of meteor or something like that. There's my meteor. And it's just hurtling through space. And light bounces off it. And then we on Earth observe this transition. And you can't see that because none of this is behind, or all of it is behind a thing. So here's what's going on with this problem. And according to this problem, the photon of light which reflected off this object was in transit for 4.66 seconds. And the goal is to figure out how many miles away is that object. And we know that the speed of light is 3 times 10 to the 8 meters per second. The variable for speed of light, by the way, is c. You will see c next quarter in 161. So, all right. So there's my picture. There's the answer that's on the screen. The answer that we should get should be 868,000 miles. Again, notice that Canvas has no idea what sig figs are. So what I do is I program the answer to be plus or minus something in the last place where you should have sig figs. So I know how fast the light is going, and I know how long the light is traveling, and I need to turn time in seconds into a distance in miles. So how do I do that? I need to turn a time into a distance, and I have this right here. This speed that's involved will help me turn a time unit into a distance unit. So if I use the speed that is shown, I could figure out how many meters it traveled in this distance by using the speed of light. And then once I'm at meters, I can then do meters to kilometers or something, and then kilometers to miles. So let's do that. So I'm going to start with how long it was, and that was 4.66 seconds. And then according to my little blueprint here, I could turn seconds into meters by going seconds, meters, and I'll just put the speed of light right in that spot when I'm done. But for now, let's just work out the units here. So meters to kilometers, kilometers to miles. Those are the units that I want my answer to be in. How many miles did the photon travel? And so let's enter in all of our information. 3 times 10 to the 8 meters per second. In a kilometer, there are 1,000 meters. And in a mile, I believe it's 1.609. That looks a lot like a comma. Let me fix that. There we go. I'm going to look that up real quick just to be sure. That doesn't help anybody, but... Oops, let's do this. 1.609, so let me put the problem back there. Okay. And when I punch all this in the calculator, I should get the answer that's on the screen, and if not, I have a serious problem, and I have a lot of regrading to do. $868,862 is what my calculator says. So that's close enough, so that's good. So the formula I programmed is working. So 868,862, 6476. That's way too many sig figs, obviously. Remember on Canvas I tell you how many sig figs to use because grumble, grumble, Canvas grumble. So you should do something like this. 868,000 miles. And Canvas would accept that answer because what I actually tell Canvas to do is do this. I say, hey, look in this position and do plus or minus whatever that position is, 3, and then the rest are zeros. So if you gave me an answer between 865,000 and 871,000, you'd get it marked correct. If you didn't get it between that range, then double check that you entered your numbers correctly because what I am doing for these problems is Canvas gives you a different iteration of it every time. So if I were to go back to, let's see here. If I were to say add another copy of this problem in here, we'll just do this. Oh, that's interesting. It gave me the exact same one. It shouldn't do that. It should give me a random one. Oh, you know what? If I hit this, actually, I'll get a new version of it. There we go. So now, and you can't see it, but I'm actually in the quiz previewer. This is what it looks like when you take the quiz. That's the chat window. Hold on, let's move that back. But now you can see that now I have 2.36 seconds. And if I were to just try again, I would get a different number. So it just randomly generates quiz problems for you. That's the wrong quiz. I want this one. All right, so that was that problem. I guess we don't really need this anymore, so we'll just get rid of it. All right, what's the next problem we got? Density of metal when heated and molten is 15.81 grams per milliliter. Suppose it costs 3,000. That should be 3,073 to purchase a pound. What is the price? Oh, okay, I see. $3.73 to purchase 1 pound. What is the price of purchasing enough to fill 11.84 gallons? Okay, so let's write down all this information that we have. Let me do this, actually. This is the problem that we're doing. We'll put it in blue on the screen. Get rid of this. Now it's in gray because I clicked elsewhere and it's impossible to read. Good job, technology. Okay, so the density of the metal, 15.81 grams per milliliter. It costs $3.07 to purchase 1 pound of the metal. And I need enough metal to fill 11.84 gallons when molten. And I got to figure out what it costs to do that. So what that means is that I'm going to start with a volume in gallons. Because this is how much I need to buy, right? I need to buy 11.84 gallons worth. And I need to turn that into a cost. So how do I do that? So I got a volume right here. What can I use the volume to be turned into? Well, here's another volume here, right here. Yeah? So volume. I don't know why that looks like an M. That was meant to be a squiggle. Which will turn that into a mass. So I could turn a volume into a mass, but of course I need the volume to be in milliliters. So I need my volume to go from gallons to liters to milliliters. And once I'm there, I can then turn it into grams, which is a mass. Now that I have this mass, here's the other mass that's involved in the problem, so I could turn it into this one if I knew the conversion from grams to pounds, which I do. These are all volumes. I should have written that. Once I know how much it is in pounds, I could then turn it into money. And the only reason that I'm doing this sort of thing is because I was running out of space. So by following this process, I can go from gallons to liters, liters to milliliters. I can then use the density to turn milliliters into grams, then turn grams into pounds, and I can turn pounds into money. So let's do that. Let's start with my volume here. How many gallons did I have? I have 11.84 gallons is what I needed. I'm going to turn gallons into liters. I'm just going to follow my chart. The chart is super helpful If you don't know what you're doing, draw out the chart. I'm going to use the density to turn milliliters into grams. We'll turn grams into pounds. We'll turn pounds into money. Now I got to look up these numbers again because I don't know how many gallons are in a liter. $3.7854. We don't really need that many sig figs, so 3.785 liters per gallon. A milliliter is 10 to the minus 3 liters. I don't remember the density. What was the density? 15.81 grams per milliliter. I don't know this number. 1 pound, 2 grams. 453.59. We'll just do that. And then what is the cost? $3.07.3 per pound. And there you go. So now all we have to do is punch it in the calculator, and we're all set, right? So 11.84, 3.785, 15.81, 3.073, divided by 1 times 10 to the minus 3, times 453.6. $4,800 is what I got. More specifically, $4,799.97. There you go. Now, as written, that has 2 sig figs. Oh, sneeze. Hold on. That time I actually did sneeze. And oh, hold on. No, I'm fine now. No, I'm not. Okay. Maybe. This has 2 sig figs, but remember, Canvas is stupid and doesn't know how to deal with sig figs. So if you enter this number in as 4,800, it'll be okay. The other way that you can enter this number would be to enter it like this. And then what Canvas would do is it would immediately turn it back into this, and maybe even add 2 decimal points on it. Either way, if you do that, Canvas will accept it. Because again, remember, Canvas doesn't know what sig figs are. You need to know what sig figs are, and then round your answer to that appropriate sig fig, because if you don't, and you just print all the numbers, you might fall out of the tolerance for rounding. Depending on what conversion factors you use and how many decimal points you use. Generally speaking, that shouldn't happen, but just be careful. And if you do sig figs correctly, you should always fall within that tolerance, and you'll always be okay. Let's see what other questions we have here. Can we ask you for you to work out worksheet problems? Yes. You know, pick any worksheet problem you want. Are the questions going to be exactly like those for the quiz, so each question is from one unit, or a combination of units? There's a mixture. So you're going to see questions that are like these. So like these 2 problems that we just did could come back with different numbers, or like a different orientation, or change the unit, or something like that. Like any permutation is possible for me to do. If I can link concepts, I try to, because that's a great way to test you on stuff from early units and then later on. However, it's really hard to get like a periodic table question and a speed of light question together. I mean, I guess I could say, if a periodic table is 20 miles long and I shoot a photon back and forth across it for 3 seconds, on what element in period 4 would it land on? Like, that's kind of a bullshit question, I'm sure, but I'm not going to do something like that. Let's see here. Unit 3 quiz about the Harley and how many miles can be traveled on a tank of gas. Yes. That is the Donovan question. I believe. So we'll just add another problem from the test bank. What was this? It was Unit 3, so I gotta find it. I believe that was 4. No, that was cubic squips. We'll come back to that one. So it must have been this one. No, that was a dog. Maybe it was the first problem. I don't know. That's not in there. I gotta find it. Hold on. I gotta dig through. Where the hell is it? Is it this one? Yeah, here we go. Okay. I borrowed that one from another class, apparently, but I didn't actually add it to 140, so... Alright, so hopefully that's big enough to be able to see. I'm just reading it off the screen here. Now you'll notice that there's a bunch of bullshit in this problem that you don't care about. Like, you don't need to know what my Dwarven Rigger's name is, that he owns a Harley, or that this is in Shadowrun. Like, none of that information is useful for you. That's sort of the design of some of these questions is, do you care about the mystery planet's name where this fictitious liquid was found? No. Just draw a line through that stuff. You don't need to worry about that. What I do want you to do is be able to sort through all of the riffraff and find the relevant information. And that's right here. The motorcycle's tank has 16.41 liters. It gets this many miles per gallon. How many kilometers can it be piloted? So let me clear all. And let's sort out this information that's useful. So we have 16.41 liters of gasoline. The mileage on it is 33.8 miles per hour, gallon, not hour. And then I want to know what distance in kilometers I can go. And then if I wanted to, I guess we could, like, draw Donovan. So Donovan actually looks kind of like Dr. Robotnik, because he has a steel head. And he's a dwarf, so he has a crazy beard. There you go. I'm not an artist in 5 seconds. I could draw a better Donovan, but of course, none of that information is useful, and I can't hit undo. I can't do this, though. We can just hide him. There we go. So I have a volume of gasoline. That volume's in liters. And if I go back up here, how am I going to link volume in liters to distance? Well, the answer is I have this volume here. These are both volumes. This will turn my volume into a distance. So if I go back down here, first if I turn liters into gallons, I can then use the gas mileage that my motorcycle gets to turn my volume into a distance using the gas mileage. Then I just turn miles into kilometers and it's done, right? So let's do that. How many liters did he start with? 16.41. Ooh, that pen stroke didn't go. So according to my map that I made, I'm going to turn liters into gallons. We'll turn gallons into miles. And then we'll turn miles into kilometers. So according to the text, we get 33... Oops, that's the wrong spot to put this. 33.8 miles per 1 gallon. Got to cross out my units. I forgot to do that. Oh, I've already forgotten how many liters there were in a gallon. Was it 3.785? Got to check it. 1 gal, 2 liter. 3.785. Okay, cool. And then that was per 1 gallon. And then in 1 mile, there were 1.609 kilometers. $235.7. Oops, I didn't tab back, so the problem statement disappeared. That's YouTube. There we go. All right, what number did I get? 235.7. I only want 2 sig figs, so 236 kilometers. Hopefully that's what's on the screen. And it totally is. Look at that. There you go. That's how you do it. So you guys hopefully are getting the gist of how to do these problems. Use the information you know and make one of these little blueprints, right? This is what we've been doing all along. If you get stuck trying to think of, like, how the heck do I get from what I'm starting with to what I'm ending with, do what I'm doing up here, which isn't drawing a picture, obviously, but say, okay, this is a volume. Where else is my volume? Because that'll give you a hint of where... Oops, you can't see this. There you go. Where is my volume? Well, it's right here. Where else is there a volume? Well, it's in this conversion here. That'll convert me to length. Okay, where's my length? Oh, that's the answer. So if that helps you, definitely do it. All right, let me find the other problem about... What are we on? Cubic squips now? So let's add a problem. Let's find that. I scrolled past it, didn't I? So that was this one. Okay. So depending on which version of the problem you either got squips or bloops. We'll do squips because somebody asked for it. Okay, so this should show up when I do that. A tank of water holds a volume of 228.8 gallons. What is the volume in fictitious units? Cubic squips. Use this conversion. 1 squip is 14.1 centimeters. Okay, so let's get rid of Donovan here. I actually need to go and draw my Shadowrun characters, or at least get somebody else to do it. Someone who can do them justice. So let's see here. I have a tank of water. I'm going to just draw my tank like a cube. And that volume is 228.8 gallons. And I want to convert this into this unit, which doesn't make any sense at first read. But then I tell you that 1 squip is equal to 14.1 centimeters. Now, the first thing that you should notice is that, well, wait a second, this unit that you gave me here doesn't match this one. One of them's cubed. How the heck do I cube it? Well, I would just do this, right? Which means that I have to do this. And then the relationship should become clear. So 14.1 cubed is 2,803. We lose that sig fig, though. So this should actually be this. Thanks for giving me numbers that don't land on nice, neat sig figs canvas. I really love that. There we go. Now that you have this unit here and this unit, you should be able to say, oh, cubic centimeters is for sure a volume. I could turn gallons into cubic centimeters, and then I can turn that into this fictitious unit. So the way that we'll do that is like that. So let's give that a shot here. So I had 200 and how many was it? I can't see it. 228.8 gallons. I'm going to turn gallons into liters. Turn liters into milliliters because I'm doing these conversions because these are easy to do in my head. But again, remember, oops, that's the wrong letter. Again, remember, you could just go straight from gallons to milliliters if you had that conversion. Totally up to you. It's just whatever you have handy. 1 milliliter is 10 to the minus 3. These are equivalent. And then this relationship is what I just wrote above. That should be a decimal point. All right. Punch it in the calculator. 228.8. 3.785. 10 to the minus 3. 2.8 times 10 to the 3. I got 309.28. I can't read that number on the screen. 309? Is that what it says? Good, because that's what I got. There you go. So the whole point of this problem was to test you on that cubed relationship. Remember that you can make any relationship power that you want to by cubing everything or squaring everything or fourthing everything. I don't know if that's what's actually called or whatever. How many monies are in a pile of gold? Let's do that. Danny, we just did a similar problem to that earlier, so you can go look back on the video and just plug in your numbers. Why is this not actually working? There we go. I gotta find the Monty problem. Where is he? Here. I don't want to edit, I want to add. Alright. So... select all didn't work. Why didn't it? Why are you not letting me select all? Oh, because I didn't hit the right button. That's why. I skipped a step. Gabriel, if you can find a problem for me to do, I'll happily go over it. I can't read this. I need to... let's see here. So Monty finds exactly 26,927 gold pieces. So let's write that down. 26,927 gold pieces. And then I give you a single gold coin. So 1 gold coin. I use GP because I play Dungeons & Dragons. So 1 gold piece weighs 0.0200 pounds. And I had to actually look that up. I had to see how many coins are in a pound. According to actual Dungeons & Dragons lore, it's 50 coins to a pound, so... And so, Monty weighs 107.97 kilograms. That's a lie. Monty doesn't weigh less than me, but I just had it pick a range of numbers. And so this is the relationship that I wanted you to get out of this was, if I wanted you to figure out how many coins we had and what was their mass in Monty's, you would have to make Monty a unit. And when you do that, you just make a relationship like this. Now, this is kind of a difficult thing to notice, but the relationship here is much more straightforward. I take the number of coins and turn it into a mass, which I turn into kilograms, and then you just say, okay, well, if one orc weighs this much, how many orcs do I have? So your conversion will go, how many coins do you have? That will give you a mass. Turn it into kilograms. Wow, that's not at all what I drew. Photoshop, good job. So we'll just set up the problem. Like so. Setting up our units just like we have in our blueprint above. And now we'll fill in the numbers. 1 coin is 0.02 pounds. Kilogram is 2.204 pounds. And 107.97 kilograms is a Monty. So how many half-orcs are in my pile of coins? $2.263. I got worried because at first my calculator said 113, and I forgot this number right here. So I'm glad I found that, because otherwise I would have had an error in my calculation. Worksheet Unit 7, there's a problem asking percent abundance of 2 naturally occurring isotopes of bromine. It's number 5. Let me find that. Worksheets. There we go. Worksheet Unit 7. I gotta renumber number 7 because all of the problem numbers are wrong. So we did number 6 yesterday, so we could do number 5. Danny, can you be more specific? Like, do you have a specific problem that I can answer? Window capture. So we'll capture that. Hit the wrong button. I'll make this bigger. I just have to crop it before I can expand it. There we go. This one I actually can read, so I didn't click on Photoshop. There we go. So the atomic mass of bromine is 79.904. So that's what's on the periodic table. So if I look at bromine on the periodic table, I don't even know what element it is. 35? Yeah, it's right next to krypton. So there's its atomic weight or atomic mass. And there are 2 isotopes of bromine. So there's bromine 79. And its mass is 78.9183 AMU. There's bromine 81, which is 80 something, right? Yeah, 9163. And so our job is to figure out the percent abundance of each of these. For your question, Danny, the number of electrons will always be equal to the number of protons. Number of neutrons, I have to tell you in some way. Where are we? Oh, that's right. I got to write the problem. So remember that for percent abundance, we have the mass of whatever atom we're looking at. So that would be bromine, is going to be equal to the percent abundance of the first isotope times its mass plus the percent abundance of the second isotope times its mass. And then also remember that I have all my percents added together must equal 100%, which I'm writing as a decimal because it just makes it convenient. Then what I'm going to do is I'm going to erase this guy. I'm going to call him X. And then I'm going to erase this guy. And we'll call him Y. And there you go. So now you just have to solve for X and Y. You have a system of two equations with two unknowns, which you can solve. So how did we do that yesterday? Well, I said, I'm going to solve for one variable. I'm going to pick this one. And we'll rewrite the equation. So I've rewritten x plus y equals 1 into y equals 1 minus x. And then I'm just going to take this and I'll substitute it in here. So now we have a new equation. So we got mass of bromine is mass 79 times x plus 1 minus x to substitute my y times the mass of 81. Now I got to factor these guys out. So that'll just be 1 times mass of 81 is mass of 81 minus x times the mass of 81. And all that equals the mass of bromine. I don't need these parentheses anymore because I no longer have multiplication to deal with. Now I can move any term that doesn't have x over to the left and just keep all the x's on the right. Oops, I didn't mean to put that dot there. Now I got that. Then the last thing I can do is I can factor out this x, right? So x. And then finally I just divide by this part right here. And there you go, you're all set. So now we got to just fill in all of these numbers here. So the mass of bromine is the mass on the periodic table. So that would be 79.904 AMU. Mass of 81 is 80.9, oops, not 96, 9163. 79 is 78.9183. And 81 is the same number. And so now I can do the subtraction. The number on the top will end at this position here. These get to go to the thousandths place. Oh, my cat is so sad. She has never been pet in her life, you guys. Maya, please. Maya, no. Don't look sad at me. It makes me feel bad. Alright, so this top number is negative 1.012, it looks like. AMU. The bottom result, which I'm just going to have to do this. 78.9183 minus 80.9163. Negative 1.9980. And then when I divide negative 1.012 divided by negative 1.9980, I'll get a percentage. $50.65 is what I got. Actually, I got it as a decimal. Let me just write it as a decimal here. Remember, this is X. So now that I know that, I can go up here and say X, which was bromine 79, was this. And Y, which is bromine 81, must be 1 minus that. There you go. Now remember, you can always plug it back into the equation to see if that makes sense. So now that we have those numbers, we can take this and put it up here at this top thing. And we can see if we get the mass of bromine right here. Now, interestingly, the atomic mass of bromine is 79.9, which is very close to midway between these two. So you could have estimated right off the bat, well, if these are the only two isotopes that are available, and they weigh 78.9 and 80.9, and the average is 79.9, when you're done with the problem, you better get something that's close to 50, right? And it turns out that's exactly what happens. Bromine is one of those weird elements where there are two isotopes, but their average is not an isotope that exists, so there is no bromine 80. It's unstable. And sometimes nature just likes to fool with us, so there you go. So let's see, that was number 5 on the worksheet. The quiz answer, or the quiz number 3 problem, we just did that earlier today. So please review back on the video. You can put your numbers in for mine. If you want another percent abundance problem, we can do that. You just got to find me an example. And then I still don't quite know your question, Danny. Neutrons and protons are independent. You can have any number of neutrons for a given number of protons. Protons and electrons will always be the same number in a neutral atom. In an ion, it'll be different, but in a neutral atom, they'll be identical. Yeah, sometimes you do just have to say Baroda nature. It is now it's 3, which means we've been doing this for an hour, so we're due for a break. Let's get the break card up here. During the break, what I'd like you to do is get me more questions. Rummage through your worksheets. Find other questions that you might want to know the answer to, because we still have an hour, and I'd like to use it. If you guys have questions. Otherwise, then we just don't have anything to do. So, I'll start the timer. Refresh your drink, go take a break. I'll see you in 10 minutes. We're going to put on the "Oh no, an exam is coming" music, because I feel like that's appropriate. All right, we're back. So during the break, we had a few questions come up for another one of these types of problems. So let's do this. I can clear this guy. And it was right here. So there's 3 isotopes of oxygen. So let's write those down. So we got O16 is 15.995. And it is 99.759% abundant. Then there's oxygen 17, which is 16.99 and 0.037% abundant. And then there's oxygen 18, which is 0.204% abundant. And so we want to figure out what the mass of oxygen is for the atomic mass. So remember that the formula is percent for the first isotope, so that'd be 16, times the mass of isotope 16, plus the percent for 17 times its mass, plus the percent for 18 times its mass. And so I just need to put all of these numbers in the right spots here. So this one goes here, this one goes here, and this one goes here. Now, we need to put these as decimals, of course. So that means I have 0.99759 times 15.995 AMU. And then for the next one, I have 0.00037. Times 16.99 AMU. And 0.00204 times 17.99 AMU. And that'll give me the mass of oxygen. And so when I do all of these, so this first term, I get 15.956. For this second term, I'm only going to get 2 sig figs out of that. I get 0063, which is fine. And then the next one I get 3 sig figs. This one is 0.0367. So we'll add all those things in green together. And let's see here. So thousandths place, thousandths place, thousandths place. So we're going to keep down to the thousandths place. And the result that I got was 15.999 AMU. Which matches really close to the periodic table, so that's great. That worked out just fine. There you go, that's how you do that. Where's my cursor? There it is. Do your sig figs throughout the problem, because otherwise you're going to generate error. Remember that when you're doing different operations, you can't just punch it all in the calculator. Because if you do, you are taking numbers with you that you don't actually know, and you are creating error. Let's see here. Something like question 5 on Unit 4. I just opened that, so where is it? There we go. Boop. Can I get it in the thing? Oh, no, I can't. I cover up all my students here. Hold on. I'm just covering me up. That's fine. You don't need to see my messages. All right. How much water is in the cylinder if we add stuff to it? Now, this question actually is a lot easier if you've already read and done lab number 2. Because this is actually part C of lab number 2. Except we use aluminum. And so the premise behind this is that if I have a container, so here's my container, it's my graduated cylinder, and I have some amount of water in it. We'll say, I don't know, we'll call this X milliliters. And then I have some object, and my object is irregularly shaped. And it has some volume to it, but it's really hard to measure its volume given its irregular shape. So if I were to put this in here, you know, somehow, like I folded it or whatever, then what would end up happening is this. First, it would get all crooked. That's the first thing that would happen, for sure. So here's my object in here. Oh, wrong color. Hold on. So I put it in there. Here's where the water used to be. Here's where the water is now. So the theory behind this is, well, if I put something in to the water, it should displace its volume of water. So the volume of the water after I have added the thing in there should just be X plus Y milliliters. So if I know the two volumes, I could just add them together, because the solid will displace the liquid. So knowing that, what can we do with this? Well, I have a density. That's the density of zinc. And I have a mass of zinc, which is 9.018 grams. And I want to figure out what the new volume of water is. Well, remember that density is the same as mass over volume, right? So I know the mass and I know the density. I can figure out the volume pretty easily. Well, here's my mass. So let's figure out what the volume is. With that many grams of zinc, I'm going to divide by the density. I was going to put milliliters, but we'll put cubic centimeters here. This will give me the volume of zinc. which is 1.264 cubic centimeters, which is the same as 1.264 milliliters. So what that means is that this volume right here is the volume of my solid. And if I know how much water was initially in there, which would be this, 20.6 milliliters, according to the problem, I should just have to add these two numbers together. So that's what I'm going to do. 20.6 milliliters plus 1.264 milliliters. And of course, I'm only going to add to over here. There you go. So the final volume of the container should be 21.9 milliliters. Because I'd get 21.864 and I would round up to 21.9. Let me check that answer real quick. 25 point. The correct answer shouldn't be 1.6. Oh, wait a second, hold on. 125 minus 38.44. Which I then round to the ones place. Oh, yeah, okay, the answer should be 1.6. Here, let's go over why that is for Danny here. Boop. Oops. So this is what I believe the problem looks like. Now, you have to do the parentheses first. So if I do the subtraction, I'm going to end up rounding to this place right here, because this is the first spot where I have a sig fig and all the numbers. Then when I do the subtraction, I get 6, 8? 8, yeah. Which means this number rounds to 87. So this now up here is 87. I then do 87 divided by 54.6, and I get 87 divided by 54.6. I get 1.5934 whatever. But I can only keep 2 sig figs because this has 2 sig figs. That looks really dumb. Hold on, let me fix that. Oh, I don't know why I made a red line on my screen. What did I just do? Undo. Probably clicked on the ruler or something. This is 3 sig figs, but when we're doing division, 2 is less than 3. So I would round this answer to be 1.6. There you go. Can you run through the difference between physical and chemical properties of matter? Yes, so something that is physical its chemical formula is unchanged. But if something is a chemical process, then the chemical formula changes. And that is the definition of physical and chemical changes. But because determining formulas is very difficult at this point. Another rubric that you can use can be, can I change it back relatively easily? If it's a physical process, then yes, you can return it back to normal. But if it's a chemical process, then no. Usually that is very difficult. Now, easily is kind of a ambiguous term. For example, if I were to take a log from a tree and cut it in half with a saw, you might think, oh, that's not easily replaceable. But if you allow the wood to, like, I don't even know how you'd get that back to be one long. But cutting something into smaller pieces, you could just slide the pieces together and it's what you had before. So I would call that relatively easy. But if you burned the wood, there's not something that you can do to make it turn back into lumber again. Other than plant the ashes in the ground, grow a new tree, and then cut that tree down. That's not trivial. So when I say relatively easily, what I mean is, can you revert the change that is proposed? So worksheet 6. Let me find worksheet 6 here. And then you want the change question. Sean, can you be more specific? Because I have a bunch of these here. Like, I'm just kind of I'm scrolling them by right here. What about soap and water? Oh, what is the difference between the... Oh, so the difference is just the difference between the word property and change. A property is like an observation, but a change is like something that actually causes the matter to undergo some sort of change. Now, change could be I changed its shape, or I changed its nature, or I changed its formula, that sort of thing. Soap and water. Soap and water is a mixture, so that's a physical process. Unless you meant down here in this chart. Oh, here it is, 2F, yeah. So this would be a physical process right here, the one that I've highlighted. Because you're not actually doing chemistry with soap and water, all you're doing is mixing them. Gallium melts near room temperature. All melting is physical properties because you could then freeze it and it would go back to a solid. That's relatively straightforward to do. Also, the gallium is still gallium whether it's a solid or a liquid. It's so sudsy. I know, it's such a mess, but if you remove the water, you get the soap back. Believe it or not. You could you could boil the water away and recover this not the salt, but the soap. What soap is called a surfactant, and what it basically does is the individual soap molecules will form bubbles, and those bubbles will isolate stuff inside them, like grease and grime, and then when you rinse them away, they get washed away because the soap is soluble in water. Soap has many interesting physical qualities, but it actually doesn't do any chemistry. Which is very bizarre to think about, but is actually just what happens. Alright, what else do we have? What else can we work on? How many problems is the quiz due tomorrow? I want to say 9 or 10, but they're all very simple questions because chapter 7 and 8 are, for the most part, just like count this thing, or point at this thing, or type in this thing. Obviously, there's going to be a question like the determine the percentage or tell me the atomic mass or whatever for calculating percent abundance and isotopes on the quiz. That one was worth 2 points. We are definitely hiding that content. Let me see here if I can ban this person. Oh, I don't want to undo that, but there we go. Keep your political shit out of my stream. Any other questions from the worksheets? Remember that there are homework problems on the recommended reading pages that you can do. Looks like my chat is going to get spammed here, so make any questions that you have quick. Seriously, if you're a troll watching a teaching stream for a bunch of students who are trying to study for an exam, you can just go fuck off. You guys are cool, though, obviously, asking questions about this. Density of pure silver is this. What volume will the cylinder rise? So this is pretty similar to the question we just did with the zinc. Do I still have that on the screen? I don't. So again, if you know the volume of your silver, you can figure out what volume the water will be. So silver has a density of this, and you have this mass of it, and you initially have in your graduated cylinder, which is green for some reason. Here's how much water we have. Let's see here. 11.2. So what you'll need to do is you'll need to turn this into a volume using the density. And once you've done that, looks like I got this for my volume. Now you can just add these two together, and that'll be the final volume. And it looks like you're going to get this for your answer. Sure. Let me find that table. For the neutral atoms. Am I in worksheet 7? I'm in worksheet 6. That's why I can't find it. Yep, that's what the recordings are for. You can always review these recordings at any time. They are on YouTube for that reason. The thing about YouTube is that it might take like a few hours to process the video. Let me see if I could just do this. There we go. That's what I needed to do. Give me a second. Let me just get rid of these. Okay. Hopefully those messages will go away. They weren't showing up on my end, but I had banned them from my feed. So what about this chart would you like to talk about? I can't draw on the chart, unfortunately. I don't think I can, anyway. Can I? Sign a document. No, I don't want to do that. Highlight text. I want to do that. Oh, I know what I can do, though. Hold on. If I do this, if I make this really big, and then I do that, and then I do this. There we go. Now I can draw on it all I want. How do you find the different numbers? So what do each of these things mean? So this right here, atomic number, this is the number of protons, right? And you might say, well, wait a second, that's right there. And yeah, exactly. These two columns will be exactly the same because they're both the same thing, right? What about the number of neutrons? Well, the number of neutrons is unique. And the number of electrons, because these are neutral atoms, these will always be the same also. So if I tell you one thing, you can deduce the other ones. So yeah, anytime you see a number of electrons, that means the number of protons is going to be the same too, and so is the atomic number. So that means that if this is a neutral atom and it's got 10 electrons, it must have 10 protons, must have an atomic number of 10, and it must be neon. Then I have to figure out the mass number, which is just protons plus neutrons. That's just these two added together, right? Yeah, they're all neutral. I had to mention that up here, because if I didn't say neutral and I just said atoms, then the problem's not solvable. Well, actually, no. I could just say the word atoms, but if I had said, like, things, or, like, particles, I guess, like, if I didn't specify that they were not ions, then you're kind of stuck. But remember that an atom is always neutral, but an ion is not. And that's just sort of a definition of the term. So you can figure all of these out, although some of my formatting seems to have kind of screwed up on some of these, so that's okay. Wait a second, this is not... I have an issue here. This isn't possible. This should be a 30... That's weird. I don't know what happened in that problem. Hold on just a second. Let me look at that. Because as written, that is not... Oh! You just can't see it on there. There's actually a line here. So... Oh, shit. Okay. I couldn't see this, but there's actually a line here between these two problems. When I copied and pasted it, I lost that line. So, this 32 is actually a unique problem. So, ignore the fact that it's crossed out. Oh, I gotta hit enter in order to draw on this again. No, I hit escape? Yeah, there we go. I made an arrow an accident, but that's okay. Yeah, that solves a lot of questions, actually. Okay. But yeah, that's how you fill out that chart. Other questions? Sig figs are rounded per operation. That's correct. So whenever you change operations, you have to stop and do your sig figs because remember, you only know the numbers you have based on the sig figs. And if you keep more numbers, you're going to create more error. If you only have one type of operation, so like multiplication, you can multiply all 7 numbers together because the rules just say consider which one has the smallest number of sig figs. But if you have a problem that's like add these 2 numbers, then multiply, then add it to this number, and then multiply, and then add it to this number, then every time you change operations, you do have to stop and consider sig figs, which is really obnoxious, I know. No problem. That's what this is for. Do we have any other questions we'd like to go over? We only have about 5 more minutes left, 6 minutes or so. Do remember that you can email me at any point over the weekend, and I will try to get back to you as soon as I can. But if you have questions after class today, after watching all the videos, send me an email, and I'm more than happy to go over those problems with you. No problem at all. Don't forget, you can go over these recordings at any time you want. I think what I was saying earlier before I was so rudely interrupted by spam was that sometimes YouTube takes a while to put the videos into the rendering queue. So like after this video is done, if you have the direct link, it'll be there, but it doesn't actually put it in every resolution until it has time to render it. And once those are done, it will appear in the class playlist. So if it's not there by, like, say, midnight tonight, then email me and I can figure out what's going on. Can we go over the distinctions among laws, hypotheses, and theories real quick? Sure. So I gotta clear the screen. I was like, why can't I minimize this? Because it's a picture. Oops, why didn't that work? Huh, I can't actually delete it? That's weird. I'm on a different layer, that's why. Delete layer. Because I drew that arrow, I forgot that that's what happened. So this can now go away. We'll just delete this layer. Oop. And then this can go away. Okay. Normally I don't paste things in, so I never think like, oh yeah, I have to deal with a layer. So a hypothesis is sort of different. So a hypothesis is some sort of educated prediction about what will happen in an experiment. So generally speaking, you make your hypothesis based on what you know about a problem and say, I expect this is going to happen. Let's do a test to see if I can verify that. And when you do the experiment, you get data and conclusions that you draw out of it. And then that will help you refine your hypothesis. There's other steps in here. But if you do this enough, you start to develop some observations. So a scientific fact is reproducible, and it is an observation. And it's unique. It's for a unique experiment, and it's very specific. So, for example, sodium detonates when placed in water. A law is more of a broad, sweeping collection of facts grouped together. And it explains how matter behaves when you make those observations. So, for example, the example I keep using is when you drop elements in group 1A into water, they all detonate. So sodium is explosive, potassium is explosive, rubidium. Those would each individually be scientific facts. But all together saying that, oh, elements in this group behave this way, that would be a law. And then a theory is used to explain why things do what they do. So the theory behind why elements in group 1A explode has to do with valence electrons, which we're actually going to talk about on Tuesday. But the elements in group 1A have one valence electron, which is easily removed because their ionization energies are low. And when those electrons are removed, that energy is used to react with water, reducing it into hydrogen and oxygen gas, or hydroxide in hydrogen gas, depending on how many electrons you move around. That isn't something that we have covered in this class, but specifically, the difference between laws and theories is that one explains how matter behaves with little detail. One explains why it happens with a lot of detail. So this is detailed, and this one is just general. And there you go. That should be enough to help you differentiate on the exam. Because you're going to see those kinds of questions where it's like, tell me if it's a law, fact, or a theory. And really what you're just looking for is find the one that's super specific and unique. That's the fact. Find the one that sounds specific, but it's actually a broad family of categories. That's the law. And then find the thing that explains something in very high level of detail, and that's your theory. Okay, we're actually out of time. It's now 3:50. And that's technically when classes end, so I'm going to put this card up here. Boop. We're going to call it a day. Thanks for watching. I will see all of you on Tuesday. Hopefully, most of you will have taken the exam, and also don't hate me at that point. But good luck studying over the weekend. Make sure you are sending me questions. I am happy to answer any questions that you may have. However, I cannot answer any questions on Monday. If you email me during the exam time, I can't answer questions related to content. If you ask me a question like, hey, when is the lab due, or can I use an NQA, or like whatever like that, I can answer those. But specific course content that might be on the exam, I can't answer it. You just won't get a reply. Okay. All right. Best of luck, and remember, good luck. We are all counting on you. And yeah, don't forget the quiz that is soft deadline tomorrow, like it says at the bottom.